Okay, today we're going to solve, like I stated in the previous video, problems where the base of the index numbers are not the same. So we have 27 m raised to the power 3 n raised to the power 4 divided by n 9 m raised to the power 2, let's say n raised to the power 3. Okay, we want to solve this problem now, and we want to use the laws of indices to solve. Now, something you need to have at the back of your mind every time you're solving an index, a problem in indices where the bases are not the same. First thing you're going to have in your mind is, how can I make the bases to be the same? All right, because it's possible to make the base to be the same even though they were not the same when the question was first given. You can maneuver and find a way to make the bases the same. That's if it's possible. If it's not possible, then you're going to solve it the manual mode. All right, so in order to make the bases the same, you need to be familiar with your factors, multiples, and all that. You should know that whenever you see 27 and 9, you know that 3 is a common factor between 27 and 9, is the least common factor between 27 and 9, and so we can try to put 27 and 9, we'll try to make them the same by making each of them have 3 as the base, and then to whichever power it may be. What do I mean by that? This 27 is the same thing. If we put it in 3, we have 3 times 3 should give us 9, and 9 times 3 will give us 27. So you see, 27 is the same thing as 3 raised to the power 3. We have put it in an index form, and then we have given it a base and a power. 9 is the same thing as 3 times 3, and 3 times 3 is the same thing as 3 raised to the power 2. We want to put them in an index form so we can be able to use it to solve this problem, because m is an index form, n is in an index form, and so forth. So that's why we want to put them in index form so we can begin to use it to solve the problem. So do you see how we have done that? Now, assuming it was 25, the first thing you should think about is 5. So the first thing that should come to your mind whenever you're solving an index problem where the bases are not the same is, how can I make the bases to be the same? That's very simple. Just make the bases to be the same, and then the problem becomes very easy, and then you begin to now utilize and further appreciate those laws that we did previously in the former video. Now we know that 27, like I stated earlier, is the same thing as, let's put it equal, the same thing as 3 raised to the power 3 m raised to the power 3 n raised to the power 4 divided by 9 is the same thing as 3 raised to the power 2 m raised to the power 2 n raised to the power 3. Now this is division, and then we're going to use the division law where it says that where the bases are the same, we are going to just subtract the powers. That's very simple, right? Now what are we going to do? Oh, I'm making a mistake there, please. This is not 3 raised to the power 2, rather it's 3 raised to the power 3, because 3 raised to the power 3 is going to give you 27. So according to the division law, let me state it somewhere again. A raised to the power x divided by a raised to the power y is going to give you a raised to the power x minus y. You subtract the power, so 3 is the same as 3 there, m is similar there, and n is similar there. So everything now is the same, so we can use the division law throughout the equation. So this is going to be, we pick 3 first, we pick these 3, they are common, so we pick them first. 3 raised to the power, this 3 is the first one, so we write 3 minus 2. All right, we are done with 3. Then let's go with m. So we have m raised to the power, the first one there is 3 minus 2 again, and then we'll go with n finally. So we have n raised to the power 4 minus 3 again, and this is going to give you equal to 3 minus 2 is same as 3 raised to the power 1. 3 minus 2 is the same thing as m raised to the power 1. 4 minus 3 is the same thing as m raised to the power 1. So finally this will give you 3 raised to the power 1 is 3, m raised to the power 1 is m, and n raised to the power 1 is n. Our final answer is 3mn, and that's very simple. So whenever you're given a problem like this, your first objective is to make sure that you get the bases to be the same, and immediately the bases are the same, you can quickly find your way through the problem. So let's make space there so we can solve another problem. I want us to look at a problem when we have the index as an exponent, I want us to look at the problem where we have the index as the exponent. So we're going to solve a very simple one. Let's say we have let me get my pen then. Let's say we have 16 raised to the power x minus 2 and is divided by 2 raised to the power 3x plus 1. So once you solve this kind of problem, how do we solve this now? You find out that this is an exponent because the power there, we have an unknown variable as the power, and also here this we have an unknown variable and we have an unknown variable. So this is called an exponent, right? So now we notice that 2 is also a factor of 16. You know, they are if you start multiplying 2 in each if you start multiplying 2 continuously, you're going to get to a point where you're going to get 16. So we can put 16 in the base 2. Alright, so 16 is equal to 2 times 2, which is 4. 4 times 2 is 8. 8 times 2 is 16. That means 16 is 2 raised to the power 4. You see that immediately you put the bases and make them to be the same, it becomes very, very easy for you to solve. So let's replace 16 with 2 raised to the power 4. So 16 is now 2 raised to the power 4. However, there is already a power there, which is x minus 2. You're not throwing it away. It's still there, x minus 2 divided by 2 raised to the power 3x plus 1. Let me get rid of this. You might need that to solve. So the bases are the same now. We can solve 2 raised to the power 4 raised to the power x minus 2. Now if you can remember your power law, we have where a raised to the power x raised to the power y is equal to a raised to the power x times y equal to a raised to the power xy. So we're using it there. So this is going to be equal to 2 raised to the power 4 times x minus 2. Alright, it's very good to put it in a bracket so you don't make mistake with the signs, please, very important. So this is same thing as 2 raised to the power 4 times x. So opening the bracket now, 4 times x will give us 4x. 4 times negative 2 will give us negative 8 divided by 2 raised to the power 3x plus 1. Alright, so if we have that now, finally we're now going to use the division law because the bases are the same. This is 2 here and this is 2 here. So we're going to now use the division law and we're going to subtract the power. Remember, division law, you subtract the powers. So this is going to be equal to, take 1 2 there, 2 raised to power 8 minus, we now have 3x plus 1. Please put 1 in the bracket so you don't make mistake, because when this bracket is going to open now, this they are going to have a negative sign there. This is the same thing as 2 raised to the power 4x minus 8 minus, open the bracket. Whenever minus open the bracket, the signs are going to change. Of course, this is going to be negative 3x minus plus is going to give you minus power 4x. We are collecting like terms now. 4x minus 3x minus 8 minus 1. And finally this is equal to 4x minus 3x is just x, minus 8 minus 1 is minus 9. So our final answer is 2 raised to the power x minus 9, and that is the answer there, 2 raised to the power x minus 9. So that's the answer for this question. Thank you for following through this question. I want you to, if you have not subscribed to this YouTube channel, do it to subscribe for more videos as this, and God bless you in no small way. Thank you so much.